Okay, the objective of this series of videos will be about numbering system. Most importantly, we will learn how to convert from one base to another. What do I mean by base? When we count in our regular life, we count in what we call decimal, or what we mean by that, it's a base 10. So we count from 0 to 9. Then what happens after that, we repeat the pattern, but we add another digit. So in decimal numbering system, we would have values like 0, 1, 2, 3, up to 9. And then what happens is we repeat the pattern. Here's our 0, and we add an extra digit. So the next one again is 1, 1. And again, we're repeating this one right here. Then the next one is 1, 2. We're repeating this one in here. But for the next series until 1, 9, as you can see, this was the last part of 10 counts. So this is all 10 counts. And we're doing the same thing here. It's 10 counts. What happens is now is we start over again, but notice we increase the second digit by 1. And then again, 2, 1, etc. until we reach 2, 9. And again, this will be 10 counts. Okay? And this goes on until we reach 99. Now, what happens after 99? Well, we've used up every possible value each digit can reach, because this is the baseline for each digit. And this is why it's called decimal, the base. So what happens here? Just like when we expired, we couldn't go beyond this. So what do? We added another digit, and we start again from here. So now our pattern will be 0, 0, 1, which is 100. Okay, so this keeps on going, and we're going to be repeating this over just like we did with the first batch until we reach 9, 9, 9. And then what happens? And again, each one of these digits have reached its maximum. Then we add an extra digit and reset the others to 0. Now we're all familiar with this kind of counting. But now we need to understand the mechanics behind it. And again, this is what we call decimal or base 10. Okay, so base 10 means you count from 0 to 9. So this is 10 counts. Excellent. So now if you were to think about any other base, so are they numbers that are expressed in other bases? Absolutely. And that would be the purpose of these videos as we move forward. Specifically in our domain, we would like to know about base 2, which we refer to as binary. And we also would like to know base 16, which we define as hexadecimal, or short for hex. Base 8, which we call octal. Okay, so these are pretty common in our industry, in programming, or in mostly engineering related to computers and computer hardware architecture. So we use a lot of these. Okay. So we will see, we will do a lot of examples of conversions. How do we go from base 10 to base 2, base 16, and base 8? How about vice versa? How do we go from base 2 to 10, base 16 to this, base 18 to 10? How about between them? Base 8 to base 16, base 2 to base 8, and how about base 8 to base 2. So we want to be able to convert. So let's say I have a number like this, 1, 2, and I put a 16 next to it, which means this is the base. This means this is a hexadecimal number. It is different than a 12 with either the letter D or 10 next to it. By the way, this 12 here also can be expressed as 12H. Okay? So these two numbers are not equal, right? But each one of them can be converted. So this 12 hex can be converted to decimal. This 12 decimal can be converted to its equivalent in hex. Okay? So in the next videos, we're going to be looking at these conversions. Now, why do we need these bases? Okay? Well, let's make the case for base 2, binary. Okay? So binary. What do we mean by binary? Binary means two things. Right? 1, true, false. 0, 1. Well, how does that relate to counting or as a numbering system? Well, remember the pattern we just had here? So let's start counting. So let's say 0 is our first number. And 0 will be always the first number in any numbering system. So the next number will be 1. Now binary, since it's a base 2, then the count is 2. Have we reached the count? And yes. So we have a count of 2. So what's the next rule? You're going to have to add, you need to add another digit. And how do you do that? Well, you're going to have to reset. Okay? And just like we did here, reset and add a digit. It's the same thing. So 0, 1, we've counted to this, and then, so this is the max you can reach. You can either write 0 or a 1 within that base for a single digit. And then notice now we need 2 digits to go beyond that. So are there permutations beyond this? Yes. Then the next one will be this, 1, 1. But now we've reached the max count we could do with this. Right? Because just like this one, for example, we've reached the max count. So what do we need to do? We need to reset the 2 that we had and add an extra digit. Same thing here. Reset the ones that you had here, and there you go. And that's how you're going to count in binary. So if you're counting that in binary and you want to convert it to its version in decimal, so this would be 0 in decimal. This would be 1 in decimal. You could write 10 if you want, or D. This number right here will be 2 in decimal. This number right here will be 3 in decimal. And this number right here will be 4 in decimal. So yes, we counted from 0, 1, 2, 3, 4 in binary. 0, 1, 1, 0, 1, 1, 1, 0, 0. So now what we would like to do in the next video is to explore, and we'll start with binary, explore it even further, make sure that we understand how to convert to decimal, and we would like to convert from decimal to binary. Once we understand that mechanism, then we should be able to apply it to any of these base numbers. See you in the next video.